try to solve this question. So in this question it will ask that calculate relative molecular mass or the molecular weight of 290 ml of a gas A at 17 degrees Celsius and 1520 millimeter pressure, which weighs 2.73 gram at s.t.p. and it is given that the 1 liter of hydrogen at s.t.p. weighs 0.09 gram. Okay, so now let's see what is need to be calculated. So we need to calculate the relative molecular mass or the molecular weight. Okay, we need to calculate relative molecular mass, or we can say molecular weight. Okay, and what is the formula for the molecular weight? The molecular weight is equals to 2 into vapor density. Okay, what is the formula for the molecular weight? 2 into vapor density. Okay, so first we have to calculate the vapor density, and then after calculating the vapor density we'll put the numbers over here and we'll multiply it with 2 and we'll get the molecular weight. Okay, so okay, let's see what is given for this numerical. So it is given that 290 ml of a gas A at 1700 degrees Celsius, 17 degrees Celsius and 1520 millimeter pressure, which weighs 2.73 gram at s.t.p. Okay, now it's little bit tricky, but let's try to understand what is given. That it is given that this is a 290 ml gas A. If you measure the volume, it comes out to be 290 ml, but the current the volume which is 290 ml is coming, it is coming at 17 degrees Celsius and 1520 millimeter pressure and not at the s.t.p. condition. Okay sir, then what is the s.t.p. condition? The s.t.p. condition is 0 degrees Celsius and 760 millimeter pressure. At this s.t.p. condition, the gas A is weighing, if you weigh, it is coming 2.73 gram. Okay, then what's the problem? The problem is we don't know this volume. We are not knowing what is the volume at s.t.p. But how that is affecting in this numerical? The problem is when you see the vapor density, formula of vapor density, it says the mass of given volume of a gas upon mass of a same volume of a hydrogen. That means, let's suppose I have a gas A. Okay, what I have to do? I have to take the 1 liter of the gas A and I have to weigh it. Whatever the mass comes, that I have to put in the numerator. Now, I'll take a gas hydrogen. I'll take a 1 liter of it, I'll measure it, and whatever the mass comes, that I'll put in the denominator. Are you guys understanding? The thing is, we have to put the mass in the numerator as well as denominator, but volume of both the gases should be same. And why I said 1 liter? Because it is given that 1 liter of hydrogen at s.t.p. weighs 0.09. So we are sorted with the denominator, which is that is, then the denominator 0.09 is gonna come, but we are not knowing what is gonna come in the numerator. Why? Because first thing, we know that 2.73 gram is given, but at what volume? Is it at 1000 ml? Is it as a 500 ml? Is it at some random number? We don't know. So that's why we need to calculate this xml, the volume at s.t.p. And now, if the volume comes out to be 1000 ml, we're gonna put the 2.73 straightforward. But if some different number comes, then we can calculate that if at this volume the mass is 2.73, then at 1000 ml it would be x. And that's how we're gonna solve this question. Okay, let's see. Okay, so but the pressure, volume and temperature are given, but at different physical condition and not at the s.t.p. condition. Then what should we do? What should we do? We should use the gas equation. What is the gas equation? P1 V1 upon T1 is equals to P2 V2 upon T2. Now assume that the P1 V1 and T1 are at the given condition. Okay, are at the given condition, which is nothing but the 1700 degrees Celsius and 1520 millimeter pressure. Okay, and the P2 V2 and T2 are nothing but the physical conditions at s.t.p. which is nothing but, what is the physical condition that has to be? 0 degrees Celsius and 760 millimeter pressure. Okay, now let's try to solve this question in order to calculate the volume at s.t.p. Okay, is the pressure known? Yes, the pressure given was 1520. Volume, it was given 290. Temperature, it was given 17 degrees Celsius. But Are we going to put the 17 degrees Celsius? No. What do? We have to convert this degree Celsius into Kelvin by adding 273.15. But for simpler mathematics, what we're going to do? We're going to add only 273. So when you add 273 into 17, 7 plus 3 going to be 10, 7 plus 2 going to be 9, 290. So divide by 290 is equal to, is the pressure known at s.t.p? Yes, 760. 760 into, is the volume known? No, that's a what? That's the volume which we need to calculate, the volume at s.t.p. Now the temperature. What is temperature given at s.t.p? 0 degrees Celsius. But as we cannot use the degree Celsius, what should we do? We have to add 273. So 0 plus 273 is 273. So in the denominator it will come 273. Now what should we do? We have to make the changes, that is volume, V2 in the LHS and all the numbers on the RHS. That is 1520 into 290 into 273 divided by 290 into 760. Okay. Now 290 to 90 will get cancelled, and when you solve the rest of the numbers, you get the answer. The answer is equals to 546 ml. Okay. What is the volume at s.t.p? 546 ml. Okay. Now understand the thing. This mass, the 2.73 at s.t.p means the 546 ml. Okay, at s.t.p, that gas, if you measure the volume of that gas, it was 546, and 546 ml comes out to be 273 gram. Okay, so what is the mass of this gas at 1000 ml? Okay, so x is equals to 2.73 into 1000 divided by 546. Okay, when you solve this fraction, you get the answer 5 gram. Okay, if anyone has doubt that why only 1000 ml, so it's very clear, because the mass of the hydrogen is given at about 1 liter, which is nothing but the 1000 ml. Okay, which is nothing but the 1000 ml. So the volume at the hydrogen is 1000 ml. The volume of the given gas is also 1000 ml. Both the gas 1000 ml weighing particular mass. That mass we need to put in this formula of vapor density. Okay, so now we know that gas A at s.t.p weighs, if you measure the volume, is 1000 ml, and that 1000 ml weighs 5 gram. Okay, if we talk about the hydrogen at s.t.p, it is, if you measure the volume, it is 1000 ml, but it is weighing 0.09 gram. Okay, now in the formula of vapor density, we're gonna put this both the values, that is 5 gram divided by 0.09. Okay, when you solve this fraction, 5 gram upon 0.09, you get the answer 55.55. Now what is about the unit? Okay, what is the unit of vapor density? It is a unitless quantity. Why it is a unitless quantity? Sir, it is a unitless quantity because the vapor density is a ratio of similar physical quantity, mass upon mass, gram upon gram. So gram and gram gets cancelled and we left with nothing. Okay, so what is the vapor density? Only 55.55. Okay, now we have to calculate the molecular weight. What is the formula of molecular weight? So 2 into vapor density. Okay, what is the vapor density? We just calculated, it is 55.55. So 2 into 55.55. Now when you multiply 2 into 55.55, you get the answer 111.11. Okay, 111.11. What about the unit? It's gram. Okay, so when you solve this type of session about the vapor density and molecular weight, the unit of the molecular weight is in gram, but the volume of, the unit of the vapor density is nothing, because it is the ratio of similar physical quantity. Okay, now let's go through this question once again. Okay, so what was asked, that we need to calculate the relative molecular mass. That was our ultimate goal. It was given that 290 ml of gas A at 17 degrees Celsius and 1520 millimeter pressure, and it was weighing 2.73 gram, but at s.t.p. So basically the volume at s.t.p was not given, and the tricky part was to calculate the volume at s.t.p, because in this formula of vapor density, both the gases has to be at s.t.p. Okay, the hydrogen was at s.t.p, but this gas was not. And how did we got to know that it is not at s.t.p. by watching this temperature and pressure condition? Because at s.t.p. the temperature is 0 degrees Celsius and pressure is 760 millimeter pressure. Then we equated both the conditions by gas equation and we got the volume at s.t.p. which was 546 ml. Then we got to know that the volume of hydrogen is 1 liter, which is nothing but 1000 ml. Then we say that if 546 ml is weighing 2.73, then 1000 ml will weigh x, and we calculate the x and we got that x is nothing but the, that is mass of a given gas at 1000 ml is 5 gram. Then we put both the values into the formula of vapor density and we got the final answer for the vapor density. Okay, and as we discussed, it's the vapor density is the ratio of similar physical quantity. It is the unitless quantity. Okay, that is no unit for the vapor density. Okay, then we substitute the number of the vapor density and we multiply it with 2 and we get the final answer, which is nothing but the molecular weight or relative molecular mass of gas A, which is nothing but 111.11 gram. I hope you understand this question. If you still have any doubt regarding the same question or any other doubts in general about, and you can comment your doubts and we'll try to solve those questions and we'll upload the video specifically for your doubts. I hope you understand. See you soon.